Impedance diagram. A resistance resists the flow of current by opposing free electron movement. Each element has some resistance. For example, an inductor L has some resistance and capacitor C is having some resistance. And we know that in the resistor element there is no phase difference between voltage and current. In case of pure inductance, the current lags behind the voltage by 90 degrees, whereas in pure capacitance, the current leads voltage by 90 degrees. Almost all electrical circuits offer impedance to the flow of current. Impedance is the complex quantity having a real and imaginary parts. Real parts represents the resistance, whereas imaginary part represents the reactance. Consider RL series circuit which is connected to AC voltage source voltage that is equals to Vm e to the power of j omega t, which is nothing but Vm cos omega t plus j sin omega t R L. Now the current flowing through it is I t. I of t equals to Im. This is also having real and imaginary parts. Applying KVL for this, the voltage Vs is equals to R I of t plus L di of t by dt. Now substitute these functions in this. Vm e to the power of j omega t equals to R into Im e to the power of j omega t plus L d by dt of Im e to the power of j omega t. Now R Im e to the power of j omega t plus L. Now if you differentiate, Im is a constant, comes out e to the power of j omega t e to the power of j omega t with respect to t, so j omega comes here. R plus j omega L of Im e to the power of j omega t. This is Vm e to the power of j omega t. Simply you can write this is Vs or V of t is equals to R plus j omega L of I of t. Now the impedance Z is nothing but R plus j omega L. This can be written as R plus j XL. Here this is the real part, resistance, and this is imaginary part, reactance. XL is given by omega L, where omega is 2 pi f L. The magnitude of Z, impedance, is given by square root of R square plus omega L square, and the angle is given by theta equals to tan inverse of omega L by R. Now this is the impedance. Z is also known as complex impedance. Complex impedance is the total opposition offered by the circuit elements to the AC current and can be displayed on the complex plane. Real axis, imaginary axis J. Now R is here and here on a y-axis XL or reactance. Then this is Z. The impedance is the vector sum of resistance and inductive reactance. And this is the angle theta. This is XL, so this is also XL. This theta is given by this formula. This is impedance diagram for RL circuit. Now consider RC series circuit connected to the alternating voltage Vm e to the power of j omega t, where V of t is equals to Vm e to the power of j omega t is equals to Vm cos omega t, real one, and imaginary one, j sin omega t. The current flows through it, I of t is equals to Im e to the power of j omega t, which equals to Im cos omega t plus j sin omega t. Now applying KVL to this, V of t equals to R I of t plus 1 by c integral I of t. Substitute that. Vm e to the power of j omega t is equals to R Im e to the power of j omega t plus by c integral Im e to the power of j omega t dt. This is R Im e to the power of j omega t plus Im is constant, so Im by C e to the power of j omega t when you integrate divided by j omega. This we can write r plus 1 by j omega c of Im e to the power of j omega t. Vt equals to r plus 1 by j omega c of I of t. This also can be written as r minus j by omega c I of t. The impedance Z is given by r minus j by omega c, and this is real part resistance, this is reactance. This reactance is due to capacitor, so this is xc, and which is given by 1 by omega c, which equals to 1 by 2 pi fc. Now the magnitude of Z is given by square root of r square plus xc square, and the angle theta is given by tan inverse of xc by r. Xc is 1 by omega cr. Impedance diagram. R, xc, this is the Z. This theta is given by the formula, and Z is given by this formula, or else Z is the vector sum of r bar plus xc bar.